Thank you. I'm Laksh, and I am working with Cisco for the past 2.5 years. Uh, I have an overall experience of 8 years in the networking domain, and my main area is in the routing and switching, which most of us or most of you guys, if you have studied computer networks in your engineering, you would have come across routing and switching in your curriculum. So based on that, today, what we will be learning is, let me start sharing my screen first. So I hope you can see my screen. So what we will be learning today is about the network layer in the OSI layer model and how different networking devices make use of this network layer. What are the components in a network layer, how network layer functions, and how a routing decision by a router or any other networking device which has a routing capability can route your traffic from one network or one network to the other network. So let's get started here. And at any point of time you do not see my screen, please do let me know. So, okay, so network layer. So here, as I had already mentioned, we would be learning the basic of the network layer. So as you all know that the network layer in our OSI model, right? Here, if you can see, the OSI model is given and all the other layers in the OSI model is faded except for the network one. So we have application layer at the top, then the presentation, session, transport layer, and at the third level, we have network layer and the data link layer and the physical layer. So whenever, why, first of all, why do we need a network layer? Okay, so in your network layer, what happens? The work of a network layer in any networking device is to create a datagram. Any what do you call, any envelope or any packet or any whatever you want to understand this, any packet in network layer is called as a datagram. The work of a network layer is to create a datagram, and this datagram will contain your information that has been transferred from the application layer down to the network layer. Okay, so the work of the network layer as given in this particular diagram is to transfer that particular information from one end to the other end. So this is point A in the network and this is point B in the network. So the work is to transfer your datagram or your packet from point A to point B. Now, to reach from point A to point B, you need IP addresses. So as mentioned here, these are the IP addresses, right? What are IP addresses? IP addresses are nothing but a name. You can call it a name in computer networks. It is a name of a device, right? So if device A wants to send some information to device B, it needs an IP address, then only it can send the data. It is just similar to our postal codes or postal address. So like, you know, so a house, let's say a house in Ahmedabad, a house in Ahmedabad is here, and this is a house in Bombay. Okay, so if these IP addresses, if the IP or if you want to send some information or if you want to send a letter from Ahmedabad to Bombay, you need the address of the person who is in Bombay, right? So similarly, in your computer networks, every networking device has an IP address. That IP address is denoted like this. So we would also understand how these IP addresses work in later slides. So as I had mentioned in the previous diagram, that your data that is coming from your application layer, you have an application layer that is sitting in layer 7, right? And your network layer or your datagram or your packet is in layer 3. So this data that is created or the information that is created in layer 7 is passed down to the layer 3, that is your network layer. So how is it passed down? It is passed down using encapsulation. Okay, basically encapsulation is nothing but to cover. You can imagine your encapsulation like a letter or an envelope. Okay, so you have an envelope. In this envelope, you have some information inside, correct? You have some information inside. So this information similarly in computer networks is passed down from layer 7 to layer 3. How? So similarly in application layer, you will have some information that is given down to layer 5. Okay, let me layer 6 here, then layer 5, then layer 4, and finally down to layer 3. So if you open this particular envelope in your network layer, you will see a data of layer 4. When you open the envelope in layer 4, you will see a data of layer 5. Similarly, if you keep opening each and every envelope, you will see the data of the previous layer. Okay, this is how usually enveloping happens. Envelope is to keep covering envelope over another envelope over another envelope. Then that is called as encapsulation. As mentioned here, that is called as encapsulation. Okay, so you're covering one cover over another and then other. That is called as encapsulation. Now, similarly, encapsulation happens from top layer, your top layer to the bottom layer, that is your physical layer. Okay, so encapsulation happens like this. Now, decapsulation. Okay, there is another thing called as decapsulation. This decapsulation happens from bottom layer to top, that is your layer 7. Okay, so your encapsulation happens when you are sending a data, and your decapsulation happens when you are receiving a data. Okay, so similar encapsulation and decapsulation also happens in your network layer. Okay, so your network layer encapsulates the segment. As mentioned here, your network layer encapsulates, okay, encapsulates the data that is in the transport layer into its data field, in the data field of network layer, in the data field of network layer. This is where your encapsulation happens. Okay, moving on. So what are the characteristics of an IP? Okay, basically IP is what you call as internet protocol. Internet protocol is IP. So in network layer, internet protocol works in the network layer. So what is an IP? Okay, what is an IP? You can understand IP in our real-time scenario. Okay, for example, all of you guys are from Tamil Nadu. So for example, let's take this city as Coimbatore. Okay, and you have Salem, Erode, etc. You have different cities. Chennai. So you have different cities in Tamil Nadu. Okay, so to reach these different cities, you have roads. Okay, you have roads, or you have railway tracks, or you can go via flight if there is an airport. Okay, so you have roads and you can connect. So you can think of IP as these roads. Roads help you to reach from one city to other city. That is the work of IP. Okay, IP you can think of as the roads that connect different networking devices. So in your previous few sessions, you would have come across few terms like routers and switches, right? So these are few of the networking devices. So when we talk about network layer, we always talk about routers, because routers has the capability to understand IP. Okay, so routers are placed in each of these cities, and the link that is created between each routers is an IP. Now, what are the characteristics of this IP? Let us understand with the same real-time scenario that I have drawn. It says it is connectionless. What do you mean by connectionless? Connectionless meaning that it will not, connectionless meaning that you do not know if your traffic has reached the other end. Okay, meaning that, let me draw those cities in a smaller way, or consider those cities as these routers. So you have router 1, router 2, router 3, and router 4. Okay, consider these as your cities in your state. Okay, so let us say that this is, as we had mentioned, this was Coimbatore, right? And this was Chennai, Salem, Erode, right? Now, when you are traveling via a road, let's say from Coimbatore to Chennai, you're going. Okay. Now, when you are going, can this road, this link, okay, can this link, or can this city, or each of these city, Chennai or Coimbatore, can they tell, have you reached safely? Have you started from Coimbatore, or have you reached Chennai? Is there a way to find that out? No, these roads or these links cannot tell. That is why they are connectionless. Connectionless meaning you do not have a guarantee if they have reached there or not, because there is no acknowledgement. There is no acknowledgement in these links. Okay, that is why IP is connectionless. Okay, similarly, here, if you read this third point, the destination will receive the packet when it arrives, but no pre-notifications are sent by IP. So if you are starting from Coimbatore, okay, if let's say that your relatives live here, okay, for example, your family is here, okay, and you started from Coimbatore. So until and unless you reach Chennai, your family will not know that you have reached Chennai, provided you do not use mobile phones, or think that this was back in area when there was no mobile phones, nothing. Okay, so once you start from Coimbatore, and until unless you reach Chennai, your family will not know that you have reached Chennai. Similarly, in IP, once the packet reaches the destination, then only that particular router or that particular city in this scenario, or your family will know that you have reached. No pre-notification is sent by IP. So if you need a proper connectivity, if you need that, if you need the acknowledgement that is mentioned here, if you need an acknowledgement or if you need a notification, who does that? That is done by the TCP layer that is sitting on layer 4 above the network layer. That is the work of TCP layer. Okay, moving on. So best effort. So as I had mentioned, from if you are going from Coimbatore to Chennai, there are different ways to reach Chennai from Coimbatore. Okay, so IP, your IP takes the best effort. Okay, best effort meaning it will find out the best route. It will find out the best route, best road, best path to reach from Coimbatore to Chennai. That is how even you do. When you open Google Maps and you do a check from Coimbatore to Chennai, the Google Map shows you the best path to reach Chennai. Similarly, IP does the same thing. IP finds out which is the best path to reach Chennai, but it does not give you a guarantee of the delivery. Okay, it does not guarantee the what do you call? It does not guarantee the delivery. Also, in between, if there are more, let's say you're traveling alone, for example. Okay, you're traveling alone in a car. Okay, you have a huge car, for example, Innova. You're traveling, right? And on the way, you started picking up people. So it does not also reduce, or it does not even stop other people from getting inside the car. You do not have the control. So you have Innova is a 7-seater people. So you ask 7 people to get inside also. That kind of reduction or that kind of control also the IP does not have. Okay. IP does not acknowledge packets as we had seen earlier. Okay. And also, if now you started from Coimbatore towards Chennai. Okay. But do you know how this road is? Is this road good? Is this road bad? If this road, if there are any construction going on in between Coimbatore and Chennai, you don't know. So similarly, IP does not know if the other device, if this city is even reachable or not, if this link is good or not. It does not know all these things. So what is the use of IP? Okay, IP is just giving you a path from going from one end to the other end. However, who controls all this acknowledgement? That is TCP, that is sitting in layer 4. Similarly, if, as I had mentioned earlier in the previous slide, where you need, there is no guarantee that the other device is reachable or not, you don't know such things at all. Who does that? So in layer 3, you have few routing protocols. You have few routing protocols. What is the work of these protocols, or what are protocols? Protocols are nothing but set of rules. You can consider protocols as set of rules. These set of rules make sure that these two routers, R1 and R2, are reachable. These two routers know about each other. They know about this link in between. All that thing is controlled by these protocols or these set of rules. So the only thing that you're doing is IP is giving you a path to reach from point A to point B. But in addition to it, so it's like IP is the road. You can call IP is your road. Okay. And protocols, you can call protocols. You have different ways, different methods to reach or use this road. You can use this road via bike. Okay, you can use this road via cycle. You can use this road via bus or your own car. So similarly, these protocol, so bike has its own set of rules, right? It has limited speed. You need to pedal this bike in order to move ahead. Similarly, bus can allow 48 number of people or 50 number of people, etc. Cycle, similarly, cycle has its own ways of moving ahead. So protocols, such protocols you help you go from point A to point B. Okay, so moving on. Here, I'll explain about MTUs later in the coming slide. So as I was explaining, right, as I was explaining earlier, IP is a road, right? So every every layer in your OSI model, has a format. So your letter, okay, when you write a letter, you have format to it. You write a to address, and then at the bottom you write from address. Okay, and then you write date, then you write subject, right, and then you give a salutation, etc. So there is a format to write a letter. So similarly, every layer, be it layer 2, layer 3, layer 4, has its own format, and only in that format other devices can read those information. Without those information, the networking devices like your router cannot understand IP. Okay, so we will understand that here. So this is your IP format, IP version 4 format. Okay, this is your IP version 4 format. So in this particular format, as I had mentioned, in just taking a real-time example of your letter, you had a to address, from address, etc. So in our IP version 4, the to address is mentioned as the source IP address. This is your to address, source IP address, and your, sorry, this is your from address. I'm sorry, this is your from address. Okay, destination IP is your to address. Where are you sending it to? Destination. Okay, similarly, there are other formats inside this header or fields inside this header. So you have a version field which tells if this particular header or this particular IP is at an IPv4 or an IPv6 header. Okay, then header length. You have something called as header length, meaning what is the size? What is the size of this particular header? So in computer networks, header matters. The size of your packet matters a lot. Okay. In hello, am I audible? Hello, am I audible? Hello, hello, am I audible? Yes, thank you. Thank you for the thumbs up. Okay, so you have different such fields: DSCP, ECN, total length, etc. So if I go into all these fields, okay, it will be a very long session, and I do not have the time to for all that, and you will also get confused. So just understand this is the format of an IP4 header. So you have a similar format for IPv6 also, which we will go through in the later section. So the IP addresses, the IPv4 addresses were actually 32 bits, 32 bits long. Similarly, destination IP address was also 32 bits long. So you had around, so the combination of IP addresses that you can have was 2 power 32. When IPv4 was created or invented, there were not many networking devices which needed IP addresses. So the people of the people who created IP addresses, they thought 2 power 32 is enough. But in today's world, 2023, 2 power 32 is not at all enough. We have so many networking devices. We have laptops, we have phones, we have smart TVs, etc. Any networking device, okay, any smart device, any networking device that is connected to internet needs an IP address. Okay, so as I had mentioned earlier, you had different fields in your IPv4 header. So you had version. Okay, so it is always given as IP version 4 or IP version 6. Since it is an IPv4 header, it will be always given as IPv4. You have few other fields like differentiated services, which, just understand, it helps in prioritizing your traffic, prioritizing your traffic. So for an example, if you're stuck in traffic, okay, if you're stuck in traffic and there is an ambulance behind you, okay, if there is an ambulance behind you, what the ambulance does, ambulance switches on its siren so that you can give way for the ambulance to move. So ambulance uses its priority, its importance. So similarly, you can give an importance to a packet inside your network. That is with the help of these differentiated services. Okay, header checksum. Checksum is like you have router 1 and router 2. For example, if router 1 is sending some information to router 2, how will router 2 know that that particular packet is not corrupted? That is detected by the header checksum. You have next field, you have something called as TTL field, time to live. Time to live meaning that if, for example, you have another router, let's say router 3, okay, for some reason, if you send a packet to R2 and then R2 sends it to R3 and R3 sends it to R1, so for some reason, I'm not going deeper into this, this packet is circulating in this network for infinite amount of time without reaching its destination. Okay, so it's a traffic congestion in the network. To avoid this, we use something called as TTL, time to live. Okay, so TTL is present in your header. If your TTL value reaches 0, if your TTL value reaches 0, that particular packet is dropped. It is discarded and it is not seen in the network forever. And how it is reduced? So when R1 sends a packet to R2, the TTL value by default is given as 255. When that particular packet reaches R2, it reduces the TTL value to 254. Similarly, when it sends to R3, the TTL value is reduced to 253. Similarly, if this TTL value goes down to 0, that particular packet is dropped. Okay. Next, we have something called as protocol field in the header. It tells what kind of packet or what kind of information it is carrying. Is it carrying an OSP? Is it carrying, like mentioned here, ICMP packet, Internet Control Message Protocol, or TCP or UDP, etc. All that information is mentioned in the protocol field. So you have something, next few fields you have as source IP address and destination IP address that I had already discussed. So as I was saying earlier, that your IPv4, okay, your IPv4 was very less, okay, was very less. You had only 2 power 32 combination of IP addresses. So as you can see here in this diagram, right, in this diagram, you have 4 billion IPv4 addresses, 4 billion IPv4 addresses. You can just simply count. Okay, there are more number of people on earth than 1 billion. Okay, 1 billion is this. You just have 4 billion people. There are more than 4 billion people on earth. But, and moreover, you have in, let's, some people have 2 mobile phones, some people have 2 laptops, some people have 2 TVs in your home. So this 4 billion IPv4 addresses is not sufficient in today's world. So IPv6 was invented or was developed. Okay, with IPv6, instead of 2 power 32, now you have 2 power 128 IP addresses. That is somewhere around this value that you see on the screen. Okay, which for now is more than sufficient, is not going to get exhausted, is not going to get empty, or is not going to get occupied or used by every devices on earth. That is why we moved on to IPv6. So the format of your IPv6 address is very similar to your IPv4, where you have a source IP address, but instead of a 32-bit, you have a 128-bit of IP address. Okay, you have version where it is mentioned as IPv6. Traffic class is similar to what I had mentioned, priority. Okay, which is similar here. So I do not want to confuse you with all these header label. Okay, now enough with all these things, like, you know, how, what is router, what is IP, what is IPv4. The main thing that an IP does is, as I was saying, it forwards the packet. It forwards it. So similarly, okay, for example, as I've been taking the example that you started from Coimbatore, okay, then you went to Salem, and then you took you took your way towards Chennai. Okay, or you can also go to Bangalore from here. Okay, now when you go towards, okay, you started from Coimbatore. For example, just think that you do not have a phone. Okay, you do not have a GPS, you don't know. You just started from Coimbatore and you reached Salem. Now you wanted to, and in Salem you reached a junction. Okay, you reached a junction, and on that junction you asked someone, okay, you asked someone how to reach Chennai. Okay, how to reach Chennai. So what this person said is that, or you asked how to reach Chennai or Bangalore. I am taking the example of Bangalore. Okay, so he says that you're on a junction. Do you know this exit path? Okay, you can go use this exit and you can reach Bangalore. This is one way of reaching Bangalore. Or that person says, go to my next city or next place, that is Krishnagiri. Okay, go to Krishnagiri and ask anyone in Krishnagiri, he will tell you how to reach Bangalore. Okay, this is how that particular person tells you. Either use this particular exit to go to Bangalore, or if you know how to reach Krishnagiri, go to Krishnagiri and ask anyone how to reach Bangalore. This is the same logic. This is the same logic that a router uses to forward your data. So for example, I have router 1 here, router 2, router 3, and router 4. Okay. So when a packet is sent by router 1, when a packet is sent by router 1, okay, towards, let's say that the packet wants to go to router 4. Okay. When it reaches router 2 says that either you can use my this exit interface to go out, okay, or you can go to my next hop, that is R3, and then ask R3 how to reach R4. You can use either of the ways. It is up to you. Okay. This is how router also does things. But in router, you have something called as a routing table. You have something called as routing table, which is very similar to a map in our hand. Okay. What that particular router does is it checks its routing table how to go to R4. Okay. Should I use my exit interface? Should I tell that person to use my exit interface or exit path? Or should I ask him to go to my next neighbor, that is R3? Okay, so similar information is provided in your routing table of a router that we will check shortly in our practical here. So here I have, I'll just go through a quick practical here. Okay, so I have a PC1 and a PC2. I have two routers, R1 and R2. They are connected using some link. Link, just imagine that this is like a path. Okay, this is like a path. So here what I will do is I will give a ping, ping, P-I-N-G, ping. What is ping? Ping is nothing but it is an actually a feature. You can call it as a feature which helps you to confirm the connectivity between two devices. Okay, it verifies connectivity between two end devices. That is the work of ping. Okay, so what I will do is I will quickly ping PC2 here from PC1, and we will also see how this works so that you can understand whatever we have gone through now. So this tool that I'm using is Cisco Packet Tracer. The tool that I'm using is Cisco Packet Tracer, where you can design your network and practice. Okay, so here the IP address, as I had mentioned, you need an IP address to reach other networking devices. The IP address of this particular PC is 10.0.0.1, and the IP address of this particular PC is 20.0.0.1. Okay, what I will do is I will ping this IP address 20.0.0.1 from this particular PC. Ping. I hope you can see the fonts 20.0.0.1. So it's saying it is pinging. Okay. Says request timed out. Let me check what is the trouble here. Okay, there was some problem because couldn't reach. So here, what I did a ping. Ping meaning I'm just trying to confirm or verify the connectivity from this particular PC to this PC here. Okay, so when I did that, it says I am receiving a reply from 20.1. That means my connectivity or my reachability from PC1 to PC2 is okay. So let us first understand how this is routed. Okay, how this is routed. So as I was mentioning here, okay, routers have something called as routing table. So with their routing table, they check how can they route a packet from one end to the other. So let's go on here. Okay, what I'm going to do is I'm just going to show you its routing table. Okay, as I had mentioned, this particular router, okay, R1, it checks how can it reach, okay, 20 network. How can it reach 20 network or 20.0.0.1? That was the IP address of PC number 2. So he says, if I want to route a packet or I want to send a packet that wants to go to 20.0.0.1 network, okay, I can send it out via 0/0/1. That is my exit interface that is mentioned here. This is my exit interface. I can send that packet out of this particular interface. Okay. Similarly, similar kind of calculation or similar kind of mapping, the other router also does. Show IP route. Okay. So here it says, if I want to reach 20.0.0.1 network or 20 network itself, I can go or I can ask the packet to use my exit interface, that is 0/0/1. That is this particular interface here. Okay. So here what it does, and let's similarly check while in a simulation manner. In this simulation manner, what we can see is how the packet is going one by one. Ping. Okay. Here, if you check, the packet is created. If I open this packet, you can see, okay, the source IP. The source IP meaning from the from address. Okay, that is the address of PC number 1. That is 10.0.0.1. Destination IP 20.0.0.1. A packet like that is created. Then what happens? This packet is sent to the nearest exit interface, that is this particular router. Okay. Now, if we open this packet that has reached router 1, okay, it sees that I have received a packet. Okay, from 10.0.0.1, and it wants to go to 20.0.0.1. So what the router does is it checks its routing table. It checks how can I reach 20.0.0.1 network. It checks its routing table. So here it says if I want to reach 20 network, I can send that particular packet out of my exit interface 0/0/1. Okay, then what it does, it forwards it out of 0/0/1. Now that packet is received on R2. R2 also does the same kind of check. I have received a packet from 10.0.0.1 and it wants to go to 20.0.0.1. How can I send this packet, or how can I reach 20 network? So if I open R2's routing table, it says 20.network can be reached by my exit interface, that is this. So what I will do is I will forward that packet out my exit interface and it reaches this PC. Okay. So this is how usually your routing happens. So this routing, be it your IPv6 or IPv4, the routing mechanism remains the same. Okay. Now, before, as I had mentioned that when I ping from this particular PC to this PC, okay, what happened was first the packet was sent to the router. Okay, only the router has the capability, to send a packet from one network. What do I mean by network? Okay, the network here is 10.0.0.0 network. Here this network was 20.0.0.0 network. Okay, similarly here you have this particular router may have a different IP address, this router may have a different IP address. So this particular PC cannot directly send a packet to PC2. It cannot send if they are on a different network. So if the packet is of a different network, the device has to send to its nearest router. Then only the router can help in sending that particular packet to a different network. Okay, so the nearest router for this particular PC, a term is given. That term is called as default gateway. Just like we have Gateway of India in Bombay. Previously, when there were no flights or trains or so ships were used, and this particular gateway of India, was used to enter India, right? So similarly, this gateway is the first step for a packet to go out of its own network. That is the meaning of gateway, default gateway. So this is a similar routing table, right? This is a similar routing table that you can also check on your PC. Okay, netstat space -r. If you do that, you can check the different destination addresses that your PC can reach, and their default gateway, the nearest exit point to reach these destination. You can also check that. So all these I had already covered with my practical, where a router forwards a particular packet using the routing table. Okay, so as I had mentioned, it either uses the exit interface, or it uses the neighbors. It says you can go to my neighbor. Okay, if you know how to reach my neighbor, use it. Go to my neighbor and check. Okay, so there are two types of routing. Basically, there are two types of routing. Okay. The one that I showed you now was static routing. Meaning static meaning I have to manually configure. Here, as mentioned here, I have to manually configure how the packet goes from one router to other router. That is the meaning of static routing. Okay. The diagram that I showed is very simple. Okay, the diagram which I showed was very simple here. This is a very simple network. But what if there are multiple routers connected? Here I have router, another router, then I have router, and these routers are also connected to multiple routers. So when your network becomes very complex, this is a very simple network, but if your network becomes very complex, manual configuration is difficult. Manual configuration is difficult. So for that, we go for something called as dynamic routing. What do you mean by dynamic? Meaning that it automatically configures the path to reach, or it automatically configures its routing table. Okay, so we use dynamic routing when we have a very complex network. Okay, so there are few dynamic routing protocols. Okay, as I mentioned, protocols mean set of rules. Okay, so few of these protocols are OSPF, EIGRP, and ISIS, intermediary system to intermediary system. OSPF stands for Open Shortest Path First. EIGRP stands for Enhanced Interior Gateway Routing Protocol. ISIS, intermediary system to intermediary system. Okay, so using these protocols, we can automatically configure the routing path that a packet can take to reach from point A to point B. That is the work of dynamic routing protocols. Okay, so as you can see here, an example of a routing table is given, which I had shown you earlier. So in this routing table, the router can see how to reach or how to forward a particular packet to its destination. Okay. All right. So any questions? I see someone had raised their hand earlier. I'm not sure who that was. So this is the end of the session, and I hope it was informational. And if there are any other doubts, and if we have time for 5 minutes, I can also clear those doubts.
I think you're good to go.
All right.
Yeah.
So
Thank you.
All right, no problem. Thank you, Ram Gautam sir.
Yeah,
No
sir. We'll
and
come.
any questions, you can forward it to us, and we'll answer them.
Sure. Thank you so much, Lux, for taking your time and attending this